All right, so let's finish this third page of the extra test 6 math. We just did the stair problem yesterday, so if you want to go check this video out, one of my favorite problems of all time. We're starting off nice and easy here, but right before we do, this is the link. This is where I'm getting this math from. One-to-one relevancy with the stuff you'll be doing on the digital SAT, and you've probably not seen these problems before, so it's really good practice. So let's get rid of that. And this first problem, let's move my camera over. A really unique graph already when I see this, but again, I'm already comparing it to problems I've seen. And if you've gone through these 4 practice tests so far, you've seen one like this too. But let's just go through the context. Let's pause ourselves before we get too far ahead. The context is it looks like it's a ball that's dropping, right? So imagine like a bouncy ball. We're starting up here and it's bouncing and it gets, less high until it eventually settles on the ground. So down here they say after it dropped, how many times was the ball at a height of 2 feet? So the whole point of this practice isn't just to be exposed to problems, but to build habits, to build inclinations. The second I see at a height of 2 feet, I'm drawing a horizontal line at 2 feet. This is going to look really similar to those other problems, those other graph problems where they say something like, how many solutions does this equation have? When they ask for just solutions, they're asking for the x-axis. So I would draw a line at the x-axis. This one, they're raising it up to a height of 2 feet. I circle my intersection points, and it looks like we're going to have 3. So really not too bad of a problem. It's all about habit building. So 23, easy. And what about 25? Already, again, I have an instant habit I want to jump into. I see a table. I see data points. Let's jump on Desmos, okay? So I pull up my Desmos. And again, if you've gone through these 4 practice sheets, you've only seen one of these so far. So I jump into this little plus sign up here. And I want to add a table. And I can actually pull this up maybe a little bit higher. Yeah, maybe like that. Okay. And I should be able to just put 2 points in here and it should be able to get me a line. So I throw in point 1. I throw in point 2. And there's one more button I have to press. And remember this from the last problem. I have to click on these little 4 dots in line and it gives me my line from 2 points. I see my equation and I'm just going to go ahead and jot that down on my problem. So y equals 3x minus 2. So that's all I need a Desmos for. I guess technically I could still use it because let me just read the problem here. So they say, so again, this is our line. So this is our line. They say, are shown in the table, what is the value of f of 3? So there's 2 different ways you could solve this. You could just stay on Desmos and say f of 3. Let's just maybe clarify that for people that are more new to this problem. When they say f of 3, remember it's usually f of x. And when you see that they're replacing the x with 3, well, if I jump on my graph, let's just go to where x is equal to 3, right? So I look on my graph here and I'm looking at 1, 2, 3, and I go up to, I don't know, it usually gives you an exact point. It looks like it's going to be about 3, 7. So it looks like when my x is 3, our graph is going to be 7. Let's get rid of Desmos real quick. So it looks like I'm looking towards b. You could also do this just using our y equals mx plus b. If I plug in our 3 here, because when x is 3, I get 9 minus 2, which also gives us 7. So again, just a good reminder to use Desmos for everything, including tables, to get our lines. Again, I don't think that's too bad. This is a classic. This is a really good problem. So just let's try to go through this, right? I look through my paragraph here and I see a gear ratio of R to S, number of teeth of 2 connected gears. The ratio of the revolutions per minute is S to R. A is turned by a motor, turning A causes B causes C. So I remember when I first saw this problem, those double ratios kind of confused me. And I thought of kind of like a different way of looking at this problem. You always want to find your kind of common ground, your common factor between everything in this problem. And I just thought, well, what would happen if I would turn gear A 20 teeth? right? So if I turned this 20, well, how much is B going to turn, right? And the commonality is the gears. So gear B would turn 20, and this one would turn 20. But we don't really like fractions, because if I turn gear B 20, it's 20 out of 60. So my greatest common multiple here is going to be 60, right? If I turn gear A, if I turn everything 60, let's just do 60 and underline it. This will turn 3 times. This will turn, this will turn once. This will turn 3 times, and this will turn 6 times, right? So we kind of have this this relationship set up now, right? So now I can read down below for what they kind of want, but I already have my nice equal relationship here. If gear A is rotated at 100 rounds or revolutions per minute, what is the number of revolutions per minute for C? So think about it. We don't care about gear B anymore, right? And the reason is because if I turn A 20 teeth, gear C is going to turn 20 teeth, right? Or if I turn A once, gear C turns twice. Does that make sense? So gear A gets a full revolution out of 20 teeth. Gear C gets 2 full revolutions. So which one is moving faster, right? And of course, C is going to be moving faster, but not just faster, but twice as fast, right? So if gear A is rotating at 100, gear C would be rotating at 200. And let me just scroll down real quick to see if that's an answer. And it does look like it's going to be an answer here. So let's just get some extra practice, right? Say they were asking about if A is at 100, what would B be at, right? And we would just do, okay, we always want that kind of common factor. So I don't want to turn gear A 20 teeth. I want to turn gear A 60. So if that turns 60, this turns 60, this would turn 3 times, and this would turn 1 time, right? So if I look down below again, if the left one is turning 100 revolutions per minute, gear B would be slower, right? Gear B is only turning once per 3 times of gear A. So I would do 100 divided by 3, and I would get something like 33.33 repeating. So is that okay? So no matter what, I always want to practice. You can always get extra practice from the same problem by going for different answers, by just changing our question. So yeah, not too bad. Always find that common ground, that common unit, which is gears. And then if I scroll up here, we have 2 left, and these, again, so many. This is probably one of my favorite tests of all time. So many good problems here. What about 29? Again, if you want to pause it, take a second, try to solve it yourself. All right, let's look at it. This motor powers a model car, and it's starting from rest, and it travels. Units are always going to be super important. So S inches, so S is in inches. T is in seconds. Those are easy enough units. And then I have an equation. I'm just going to rewrite the equation down below so it's a little bigger. S is equal to 16 T square root of T. So, you know, hypothetically, I could throw something in here. I could say, what's a good easy square root? I could put like T equals 100, right? And then I would get 10 times 16 times 10, or times 100, and I would get an amount of inches that this is moving, right? So not too bad. Which of the following gives the average speed of the car in inches per second? So let me just write that down below. This reminds me, I'm already categorizing it in my head. This is probably going to be a units problem, and I'll dive into what that means. So average speed, and I don't want to do S because S is going to be inches. So average speed is going to be equal to inches per second. Okay, inches per second over the first T seconds after it starts. So I look back at my first equation, and my first equation gets me inches, right? And this is where it's going to seem a little difficult at first, but with practice, with looking over 29 a couple times, there's another really good unit problem I'm already thinking of. We want to master being able to compare and equal units. So let's think about this. This equation up above, this right here is in inches. Do I see any other inches that they mention? And of course, they wouldn't just mention the second part. Average speed is going to be inches over seconds. So technically, if they're asking which of the following gives average speed, so I want this. To get this from my equation, I just have to throw some form of seconds on the bottom, right? I'm missing this in this equation. So to divide by seconds, I feel like they give us 2 hints. They tell us that t is seconds, but then they also give us this over the first t seconds. They're trying to push us in the correct direction. So if I put this over t, let's see if this makes sense. Originally, this equation was in inches. Average speed is going to be inches divided by seconds, so my units work. And specifically why I would use t, well, honestly, I don't know what else I would plug in for seconds, right? They try to reinforce it with this over the first t seconds. When I reduce this, let me get rid of this guy. If I try to reduce this now, it's also pretty easy, right? I see t divided by t, so t over t, and I get my average speed now, not just s, is going to be equal to 16 square root of t, and it's looking like b here. I like this problem because it's all context, right? There's no crazy mathematical formulas I have to do. This can be why this is one of the harder problems you can come across. But yeah, reinforce, try this problem again a third time, and I'll make sure to emphasize the next unit problem we come across because units can really help us. And finally, another one, and I'm not embellishing this, another one of my favorite problems I've come across. If you can figure this one out, you're going to be in really good shape. So again, pause it here if you want. Try to solve this, and let's do it. A group of friends decided to divide the 800 cost equally among themselves. Okay, so again, they give us enough context to make my equation. So right there, it's an 800 cost, and they're dividing it amongst themselves, right? So do I know how many of them there are? No, but hypothetically, if there was 100 people, right? Well, this would be $8 a person, right? So as long as I can try to just understand what my equations are saying, we don't know if there's 100 people, it's probably way less, but we know there could be X people. This is how much this is going to cost. My result is going to be amount of dollars per person, right? Kind of like a rate. So maybe X, maybe in parentheses over here, I'll say like this is people. Okay. And let's see what else they say. 2 of the friends decided not to go on the trip. Of course, it always happens. Those remaining still divided the 800 equally. So again, they're trying to help us out with my equation. Those remaining still are paying this 800 because the cost of the trip's not going to go down. But what's changed? I'm not dividing it by X. If there was 100 people to start, 2 people aren't going now. So it'd be 98. So to reflect that, I would say, well, we still have our X, but 2 people aren't going, right? And they finally give us the result here. Each friend's share of the cost is increasing. Of course, you're still going to pay the same amount in gas. You're going to pay the same amount for the hotel. There's just 2 less people, right? This is the hard part. How do I fit $20 into this problem? And how could they change this problem to where I could still grapple with it if they change some of the context? So we have this 20. Let's try to use from the previous problem some of our units. The 20 is in each friend's share of the cost is 20. So technically I could say this 20 is per person, right? So I look just at my first little fraction, and that's 800 over people, and 800 over x minus 2, which is 800 over people. So all my units match. I don't have to change this 20. Right? If they would have said something like the overall cost increased by an amount, see, I'm gonna have to change this. They gave me this nice money divided by people. The 20 fits in here perfectly. Where do I put the 20? Right? I know there has to be some sort of equal sign here because the amount per person before and the amount per person after with this increase of 20 should equal each other, right? and this is where I think a lot of people might make the mistake of, just like the if you've been going through these practice tests, that detergent and fabric softener one, where there's twice as much detergent, you don't put the 2 with the detergent, you put the 2 with the fabric softener, right? So that problem where it's like detergent equals fabric softener, I think they gave it an S. If I put the 2, they want twice as much detergent. I put the 2 with the softener, because when I plug in 1 for fabric softener, I get 2 for detergent. So try to practice that a lot of times in equations, it's going to be the opposite of what you think. It's going to be counterintuitive. So this cost over here per person is already increased by 20. So make it up. Say this gets you 80 per person. How much was it before? You can even consider this like a timeline. This will be before, this will be after. It should be more expensive after. So after it's 80 a person, before it would have been 60. So then you have to ask yourself, which one needs the 20? The 20 ironically goes to the beginning. Even though they mention it with the after, you're already paying 20 more. I need to add 20 to before to catch up to the now. So what this equation is going to turn into is I put 20 plus on this side. So again, real quick, I'll try to go through it so it makes sense. The after, when the 2 friends leave, they're paying more now. They're paying 20 more. So if this more was 80, the before would have been 60. So if I add 20 to that 60, it'll catch me up to the 80, right? So this problem back in the day when you didn't have Desmos, it was actually pretty tough to solve by hand here. But we have Desmos. Let's go ahead and pull Desmos up again and unhide it and maybe move it maybe like right here for now, just so I can type in the equation. So we're going to type in 20 plus 800 divided by x equals 800 divided by x minus 2. And I'm going to try to, I'm just going to make it take up my whole screen just so you can see what I'm seeing here. Let's see. Wow, really zoomed out. Oh no, there's my 2 solutions. We're always looking for our 2 solutions, right? I see. So my Desmos is just not working with clicking today, but I feel like I get a good enough idea, right? -5, -6, -7, -8. Let's go ahead and write down -8. And I see +10. So let's get rid of Desmos and let's analyze our results, right? So remember, we're solving for how many friends there were. So context and functions don't necessarily go hand in hand. You'll see this when you do parabolas for like an object dropping. They'll usually only show the positive side of the object dropping because your x in those equations. I mean, a really quick example. If I show like this, and they show like this object that's dropping, right? This is always going to be time. It's like over time, this object's falling to the ground. Well, if you put this actual function in Desmos, it's going to show you this. And that doesn't make sense because this is negative time. So don't get too disoriented by sometimes the context doesn't match up with the function. -8's just relative to the function. In our context, we can't have negative people. So it's always going to be there was 10 people to start. 8 people after the fact. So they want how many were there originally. It looks like our answer is going to be 10 here. So just an excellent problem. We finished this worksheet, one of my favorite worksheets. We'll be jumping into test 5 later today.